So here we are looking at the River Tay for our IGCSE in edXL. We're going to have a look at the geology of the Tay. So I'm going to just turn the geology on here. You can see this is the mouth of the Tay, and we're going all the way up to Lochte, which is its loch, which is kind of its source, and then there are a couple of tributaries that lead on to the loch. Now you can see there's a clear fault running through the middle of the basin of the Tay. One thing we can look at, if we just zoom in over here, we'll look at some rock types and how the river is behaving in relation to these rock types. So this pale pink rock type, if I click on it, should pop up. We can see that that is a sandstone with conglomerates, siltstone, mudstone. So these are sedimentary rocks, somewhat softer. They're, in terms of Scottish geology, not that old, even though Lower Devonian is extremely old. Now you can see that the River Tay seems to be cutting between these two darker pink patches. These darker pink patches are igneous intrusions. They're called dikes. Basalts, that's the lava that comes out of volcanoes in somewhere like Hawaii now. Well, this came out a long time ago. It erupted onto a surface that has now been eroded, but these are the cracks through which it rose and then it cooled in that place. And we can see that these igneous rocks, which are harder than the sandstones around them, have formed highland, and the lowland, made of sandstone and mudstone, as we looked at earlier, has been cut through by the River Tay. So that's one way we can see how the geology is interacting with the landscape here. Geology is interacting with the river, to create the landscape here. I'm now going to move up into probably what's the middle course here, and we can see that the Tay is heading broadly eastward across Scotland, and then it seems to take quite a sharp bend and start heading towards the south. And we're going to have a look at why that might be happening by zooming in on this whole area. So I'm going to zoom in here and just try and tilt. A little bit so we can see the relief a bit better. Close that down for a sec. So zooming in a bit closer, well, we can see what's kind of stopped the Tay moving east here. Look here, this kind of rock. So the river is cutting through these rocks called sammites and pellites. This is really, really old, like older than the trilobites. However, sammite and pellite, that's sandstones, mudstones, and the river's cutting through there. It seems to have been stopped by whatever this is. And we click on it and we find out it's a felsic rock, it's an igneous intrusion. So we're looking at something here that might be a granite or something of that type. And so it seems that the Tay has been travelling east and it's been diverted south because it's hit an area with some granite in it. Now, if we look in a little closer here, we can see that the Tay's down here on the valley floor and we've highland on either side, and clearly the highland has a different kind of rock than the valley floor. And so if I click on that, I can see that I have lava tough volcaniclastic rocks. So these are rocks made of lavas, or they're made of the material that exploded out of the volcano again an incredibly long time ago. But these are igneous rocks, and these igneous rocks seem to be harder than the sedimentary rocks that make up the valley floor. So the valley floor has been cut out by the river, and the river has not cut these harder igneous rocks. I'm going to continue moving up the Tay now, and here I am at Lochte. Now Lochte isn't necessarily the beginning of the river because there are rivers feeding Lochte, but the reason we're looking here, I'm going to stop here, is because we have an interesting feature just here. You can see that Lochte, which you can just about make out kind of beneath the geological map overlay, it turns sharply left as we're looking at it at this point. And the reason for that sharp turn left is this line here. This is a fault. You can see it's a fault because we've got major bands of rock that just disappear at this point, and here's another one that disappears at this point. Here the rocks have moved left and right or up and down, and that's what we call the fault. Well, that fault is also a line of weakness, and the glacier that will have carved out the valley that has formed Lochte will have gone down that fault as it was a line of weakness and cut it out. As we go further up Lochte and into the tributaries of Lochte, we can see again that on the sides we tend to have these igneous intrusions, another igneous felsic rock, so possibly a granite or something similar, and the place where the river tends to flow, where the loch is, tends to have these sedimentary rocks which are softer. So the River Tay has sedimentary rocks, or flows mainly along sedimentary rocks. Many of the areas to the side forming the highland tend to be igneous rocks, and we can see also in Lochte that part of the river channel, which in this case is a ribbon lake or a loch, is actually carved out along a fault, which provides a line of weakness along which the glacier that formed it cut.